Univariate data. Okay, univariate data means there is one set of data. There's one thing. As opposed to the regression, where you had like a X and then a Y and you'd graph them both. This is different. Okay, this is the normal curve. In this situation, the mean is in the middle, and so is the median, and so is the mode. Okay, and then you'll have these little standard deviations. It kind of helps if we draw this out a little bit. So we're going to draw 3 on each side, try to make it as symmetric as possible. I'm struggling with that, but here we go. Okay, 68% roughly, 68% of the data falls within one standard deviation of the mean. Therefore, 34% is here and 34% is here. 95% of it falls here, which means that this is 13.5 and this is 13.5%. Within 2 standard deviations, we have 95%. Within 3 standard deviations, we have 99.7%, which gives us 2.35% here and 2.35% here. Beyond that is 0.15%. Okay. What we're going to do is take this same idea with the word problem they give us and go from there. The height of football players on a football team is normally distributed, I should say are normally distributed, with a mean of 74 inches and a standard deviation of 1 inch. In other words, if I was to graph their heights, then it would be roughly a normal curve like this. So the standard deviation is 1 inch, but the mean is 74. So if this is 74 and the standard deviation is 1 inch, we're going to go up 1 each time. So up 1, up 1, up 1, and we could keep going, but let's not, and we'll go down 1, and then down 1, and then down 1. Okay, there are 50 football players on the team. How many are more than 73 inches tall? Okay, well, let's figure this out. More than 73 would be this. So we have, let's do it the backdoor way. This many of them are more than 73, so these are less numbers to add. This many are less than 73. And so therefore, 0.15 plus 2.35 plus 13.5. This percent of them, 16% of them are not more than 73, which means we subtract 100 from that. So 84% of the football players are taller than 73 inches. Don't put 84. That's not the answer. There are 84 out of 100 of them, but there aren't 100 of them. There's 50 of them. So 0.84 times the 50 people that we have. And when we do 84 times 50, we end up with 42. 42 football players. 42 football players are more than 73 inches tall. How many football players on the team are less than 7.5 inches tall? So they're going to be less than this. Whoa, 7.5? That's not on here. All right, it's about to get tricky. Hope this rings a bell. Second and distribution is the VARS button. And we're going to use option number 2. Normal CDF. We will use option number 2 when we are going to figure out a percent. We are going to use option number 3 when they give us a percentile and we have to figure out what the actual height would be. So we'll do this. And the things we type, the arguments they're called, the arguments within the parentheses are this. The lower bound, the upper bound, the standard deviation. Oops, I accidentally lied to you. It's the mean first, and then it's the standard deviation. So we're going to type this, ignore the scribble. So the lower bound, they're going to be less than 71.5 inches tall. We're going to put a really low number like -1 times 10 to the 99th. That's as pretty much as small as the calculator can deal with. Comma, you could put 0 there. It'll probably be pretty much the same. Comma, 71.5. Comma, the mean, well, they told us the mean was 74. They told us the standard deviation was 1, so boom, there we go. How many football players on the team? So 0.006% of them, 0.006, which is equal to 0.6% of them. That doesn't answer the question, how many football players on the team? Well, there are 50 of them, so 0.6 times 50, and that's 30. No, that's not right. That's not right at all. 0.006 times 50. I thought it was going to be a crazy decimal. 0.6% of them. So we take the original decimal and we multiply it by the number of people on the team. Sorry for the confusion there. My mind wasn't operating for a second. So we're going to do 0.006 times 50. And there are 0.3 players on the team that are less than 71.5 inches tall. That's not realistic. 0.3 players, that's 3/10 of one person. Yeah, not realistic in this situation. Okay, if a player's height is in the 90th percentile, what is their height? Well, don't know. What is their minimum height, I guess would be the better way of asking it. So, second distribution, and they gave us the percentile. So 0.9, here's what we'll type. We're going to type the percentile, comma, the mean, comma, standard deviation. This one's going to be pretty basic. 0.9, comma, 74, comma, 1. There we go. They have a height of 75.28 inches. Okay. All right, this bottom part is something I haven't shown you very much of, but this is going to be incredibly easy. For the set of data above, determine the mean, median, mode, and standard deviation. We can do those pretty easily. Actually, let's go ahead and jump to the chase. We know what the mode is, right? You know which one of these numbers happens the most. Actually, it's plural. There's more than one of them. 81 and 82 are the modes, both of them. So we have two modes, but we're going to find the mean and the median and the standard deviation. Let me show you what to do. Just in case you're asked a question like this, there's an easy way to do it. You won't have to type it over and over and do it all by hand. Press Stat, enter on Edit. Let's clear out some junk. Clear that out. And we're going to type them in. Might take a minute, but it really will save us time in the long run. 73, enter. 74, 74, 75, 76. 80, 380s. Whoops, messed up. 481s, 482s, a couple 83s, an 84, no 85s, two 86s, an 87, that was a very good year, 88 was also a good year. Okay. If we press Stat and go over to Calc and hit Enter on one of our stats, it'll tell us everything we need to know. Here we go. That top one, the X with the bar on it, that is the mean. So just so you can see it one more time, I'll draw it. X bar, which is the mean, and in this case, it is equal to 80.28. Isn't that nice? It gave it to you. You didn't have to type it all. Well, you had to type it all, but you won't have to type it again and again to find different things. If you scroll down, you will find the median. The median is 81. And the standard deviation. Mr. Reader, what in the world is that? That determines the level of spread, as we can tell here. You know, like if the standard deviation would have been 2, then it would have been spread out a little bit more. Standard deviation in this case, this is where it gets tricky, but the standard deviation, there's two options here. We're going to pick the S. 3.92 is our standard deviation. Here's the reason we're picking the S. S is the entire group, and this one would be if it was a sample, like if it was a smaller group. Like if this group was a small group, man, I'm confusing. A small group that represents the entire population, that would be this one. But in this case, we're going to go with the capital S and not the sigma, the lowercase sigma, the Greek letter.